One of the features or properties of atoms that we have learned this year is about electronegativity. Electronegativity is the relative attraction for bonding or valence electrons. So the higher that electronegativity is, the more pull an atom or nucleus has got on the electrons that would be involved in bonding with other atoms. The bigger the difference of electronegativity between the two atoms, let's say X and Y, the bigger the difference of electronegativity we have, the more the electrons get transferred to the one with the higher electronegativity or spend more time associated with the atom. If the two atoms, X and Y, have got the same electronegativity or very, very similar, then they create a covalent bond where they share electrons and they share them quite evenly. And we call that a non-polar covalent bond because the electrons are your sort of classic understanding of sharing. They're spending about as much time with one atom as they do with the other. We find that that's an electronegativity difference of less than 0.4. Now, in year 13, basically if the value isn't 0, then the bond has got some level of what we call polarity to it, a dipole. So in year 13, we really say, look, if it's not 0, it's got some polar properties, the bond. But it really becomes quite apparent when we get to about 0.4 as a difference. So if Y has got an electronegativity, let's say of 2.4, and X is 2.0, for example, then the difference 2.4 minus 2 would be big enough for it to be called a polar covalent bond. The electrons are spending a little bit more time with the atom that has the higher electronegativity, so in this case Y, giving it a slight negative charge. This is the lowercase delta. It's about as well as I can draw it, so you'll have to bear with me there. Basically, when I draw it, I do an S, and then I curl the back of the S around so it touches the rest of it. So I draw a capital letter S and then draw it back. So what I'm saying here is if Y has got higher electronegativity, it has a stronger pull on the bonding electrons in here, and so therefore they're going to be held closer to that nucleus, giving this side of the bond or molecule, we'll get into molecules later, this side of the bond a slightly negative charge because the electrons, although they're shared, are being pulled closer to the side of the bond. Because the number of electrons is balanced by the number of protons across this whole chemical bond, then if this side is slightly negative, this side must be slightly positive. So we call this thing a dipole. Di for two, pole for ends. It's got a slightly negative end and a slightly positive end. Now, when we get to 1.7, this attraction is so strong the electrons actually get transferred, and this is where we create our ions. So we're really at this stage only looking at molecules and the bonding within polyatomic ions. So we're looking at covalent bonds. What you need to be able to do is, if given the electronegativity values for two atoms, you need to be able to say whether it's a polar or a non-polar bond, and then label its dipole, the delta positive and the delta negative. The delta negative being the one with the higher electronegativity. I'm just going to put some numbers in here as examples to create my dipole. So let's say that this has an electronegativity of 2.0, and I'm going to change this one up just a little bit to 2.5. So the difference in electronegativity is equal to 2.5 minus 2 is 0.5. That's big enough for it to be a polar bond, so it's got a bond dipole. Slightly negative, slightly positive.